Good morning, students. Our next topic is the types of matrix. We've already covered the order of matrix and its definition. We start with the types of matrix. The very first type is the column matrix. Now, what is a column matrix? A column matrix is one which has just one column and it can have any number of rows. As you can see the example written that this particular matrix has 3 rows and 1 column. So this is an example of a column matrix. Likewise, as we come across this example, this particular matrix also has 2 rows, but it is having only 1 column. So in any case, a column matrix is one which is having only 1 column, but it can have any number of rows. Likewise, our very second type, that is a row matrix. A row matrix also is the one which has just one row and it can have any number of columns. Remember, in this particular case, the order of this matrix would change. For instance, the order of the matrix here was 3 by 1. So here it becomes, since the order is written by row into column, so it will be 1 into 3. That is 1 row and 3 columns. Likewise, if I take this example and convert it into a row matrix, so this will be A, B, that is having 1 row and having 2 columns. So its order gets changed into 1 by 2. Likewise, we have a square matrix. Now, what is a square matrix? A very important condition that is to be kept in the mind is that a square matrix is one in which the number of rows and the number of columns is the same. That is, number of rows. If a particular matrix is having 2 rows, definitely it will have 2 columns. That is, for example, 2, 1, 1, 2 is an example of 2 by 2 matrix. Remember, here the number of rows and the number of columns are exactly the same, and that's why it is referred to as a square matrix. A square matrix, since by definition it means that it can have same number of rows and same number of columns. Therefore, a square matrix can be either 3 by 3, it can be 4 by 4, it can be 1 by 1. That is, a matrix having just one element is also referred to as a square matrix. Next, we come across a diagonal matrix. Remember, the next 3 matrices, that is a diagonal matrix, a scalar matrix and an identity matrix, are type of the square matrices only. So what is a diagonal matrix? A diagonal matrix is one, remember, a diagonal matrix is one whose non-diagonal elements are 0. By non-diagonal means, for example, as I told you, that a diagonal matrix is already a type of a square matrix. That is, in a diagonal matrix also, the number of rows and the columns would be exactly the same. So let me take this as a 2 by 2 matrix. The diagonal is referred to be the elements which are lying on this particular path. So if these elements can be anything, let me say these are 1 and 2, and the non-diagonal elements are these, this and this. So these have to be 0. So this is an example of a diagonal matrix. Likewise, we have a scalar matrix. In case of a scalar matrix, this is also a square matrix of order 2 by 2. Remember, here, since the scalar matrix is also a type of a square matrix, so it is of the order 2 by 2. A scalar matrix will be also defined as a diagonal matrix. By diagonal matrix we mean that the non-diagonal elements would be 0, but the diagonal elements would be a constant value. So it can be 2 or 2, or it can be root 2 or root 2. Remember, the diagonal elements both have to be the same, any scalar quantity. Likewise, a scalar quantity can also be a 3 by 3 matrix as well. Next, we start with the identity matrix. Now, in case of an identity matrix, remember the non-diagonal elements are to be 0, 0, but the diagonal elements would be 1 and 1. So again, an identity matrix is a square matrix and a diagonal matrix as well. Diagonal because its non-diagonal elements would be 0, but since the name is identity, its diagonal elements would be unity or 1. Zero matrix. Zero matrix is a matrix whose all elements are 0. So any matrix with its element as 0 refers to a zero matrix, or it can be this. So these are the types of matrix. Another very interesting and important type of matrix is the equality matrix. Now, what is an equality matrix? Let me say I have two matrices A and B. Now, when are A and B matrices exactly the same? There are two conditions that need to be followed. First, order of A and B must be same. Second, the second condition that is very important, that the corresponding elements of both the matrices must be same. For example, I have a matrix A which is given by A11, A12, A21, A22. Likewise, I have another matrix B, B11, B11, this is B12, this is B21, and this is B22. Remember, our very first condition, that is order of matrix A and order of matrix B must be the same. So as we can see that order of A is 2 by 2, order of B is also 2 by 2. So order of both the matrices is the same, and their corresponding elements must be equal. If A11 is equal to B11, as we know the order is already the same. But if corresponding elements, by corresponding we means the first element, the element of first row and the first column of matrix 1 and likewise element of matrix 2 are equal, then we write that A11 is equal to B11. Likewise, A12 must be equal to B12. A21 is equal to B21 and A22 is equal to B22. If both these conditions are satisfied, we say that both matrix A and B are equal. So this is all about the equality of matrix. Likewise, another important thing that I want to tell you is that in a matrix, Aij represents the element of a particular matrix. Element of a matrix. This I and J, it represents the position of the element in a matrix. Remember, since the very first element, for example, if I compare it with A11, here I is 1 and J is 1. And we read an element corresponding to the first row and the first column. So I represents the value that this particular position can take will depend upon its very first position. That is, I will be greater than equal to 1 and it will be less than equal to m. That is the number of rows. Likewise, J will represent the position of the column. So its value must be greater than equal to 1 but less than equal to n. So this particular thing represents the position of the elements of a matrix.